Hello everyone. This is going to be the first video for our class and it is going to be over section 6.1. You can find that if you want to follow along in the book on page 344. Okay. And a lot of this is going to be a review to start off with. The four outcomes that we are going to go through are evaluating algebraic expressions, using mathematical models, understanding the vocabulary of algebraic expressions, and simplifying algebraic expressions. So the first topic, evaluating algebraic expressions. Oh gosh, it's the beginning of the school year and my handwriting isn't very good. Evaluating. Oh, that's terrible. Oh gosh, you guys come forward through this. I just have to rewrite this. Evaluating algebraic. Evaluating. I'll get better, you guys. Algebraic. Oh, this is horrible. I'm so sorry. Expressions. And the difference between an expression and an equation is that an equation has an equal sign, an expression does not. Okay. So the first thing this book wants to talk about is really going to take you back to middle school, I think, because we are going to talk about the order of operations. Okay. Now, as I'm writing this, okay, that's a little bit better. Operations. As I'm writing this down, are you going back through your head and trying to remember what we used to say? This is totally old school, you guys, but please excuse my dear Aunt Sally. Okay. Now, instead of P, sometimes your teachers, instead of P, which we use for parentheses, sometimes your teachers would use G for grouping symbols because it's not always your basic parenthesis that we're looking at, right? So here we have your parentheses happen first, then your exponents, and then I'm going to do this in a separate color because I think sometimes what we forget is multiplication and division. They're actually the same thing, right? Division is just multiplying by a fraction. And they actually happen at the same time, and you just do whichever comes first. If dividing comes before the multiplication, then you do the dividing first. And then after those two, it's going to be the same for addition and subtraction. They actually happen at the same time. It's just whichever one comes first, right? So then we're just going to go through, there's 3 examples that the book gives, and I'll go through those with you. And then I'm going to ask you to pause and try the checkpoint answer. Okay, so if you're following along in the book, looking at example 1 on page 345 wants us to evaluate using the order of operations, and it gives us the expression 7 plus 5 parenthesis times the quantity of x minus 4, and then that is cubed. And it wants us, whoops, sorry you guys, it wants us to evaluate this for x is equal to 6. So wherever we see an x, right, we're just going to substitute in a 6. So I'm just going to rewrite it for my own sake. 7 plus 5 times 6 minus 4 cubed. And then we're just going to go down one by one. Are there parentheses? Yes, there are. So I'm going to go ahead and do that. So then I have 7 plus 5 times 6 minus 4 is 2 cubed. So I didn't take my parentheses away because I didn't want to just change that to a multiplication sign. I think that that's something you can make the decision for yourself. I think you could say 5 times 2 cubed if you really wanted to get those parentheses out of the way, but I prefer my multiplication to have parentheses. So I'm going to keep it like this until our next part, which is doing the exponent, right? So now I'm going to have 7 plus 5 times, and like I said, I like to keep those parentheses, 2 cubed. So 2 times 2 is 4. And then again, because 2 cubed, if you remember, is 2 times 2 times 2, which is actually 8. And then we're going to do the multiplication. So 7 plus 5 times 8 is 40. Now finally, those parentheses for me are going away. And last, 7 plus 40 is 47. Okay, and let's just double check. You can go through the example in the book. It's step by step and it gives instructions. So if you didn't want to watch the video part of doing the examples and you'd rather do it out of the book, that is fine. You are more than welcome to go ahead and like fast forward through this part. But I am going to go through all of the examples here. So the next example gives us x squared plus 5x minus 3, x squared plus 5x minus 3. And we want to evaluate this expression for x is equal to negative 6. So just be aware that we have that negative there. That's what they're banking on to confuse us. So everywhere I see an x, I'm going to substitute in that negative 6. And here especially, when we square it, we're going to need to make sure we have those parentheses times 5 times negative 6 minus 3. Okay, so in this case, we're going to do, we don't really have any operations happening inside the parentheses. We just have really values or numbers inside those parentheses. So we're going to skip right on over to exponents. So this first one, negative 6 squared, and this is where it's important to remember that's negative, is really negative 6 times negative 6. So here's the other piece you don't want to forget. You don't want to forget that a negative number times a negative number is actually a positive number. So this is actually positive 36. Okay, plus, and then 5 times negative 6 minus 3. Now, if I was not doing this example step by step, I probably would have went ahead and multiplied at the same time since I realized it didn't really mess up my steps. But I do not want to do that in the middle of trying to focus on the order of operations. So next I'm going to do the multiplication, 36 plus 5 times negative 6. Now this is tricky, is negative 30. So we actually have plus a negative 30. We could just change that to minus 30. That's what I always do because it confuses me sometimes to have two operations in a row like that. So what this really means, I'm not doing anything. I'm just changing that plus and negative to just be minus because it makes more sense in my head. It may make more sense in your head the other way. That's okay. Now we want to do this in order. So 36 minus 30 is going to be 6. And 6 minus 3 is going to be 3. So our final answer in this evaluation process is 3. And that was example 2. Just for fun, for example 3, let's switch up colors. Yeah. And this time we are going to have a negative 2x squared. Here's the expression, negative 2x squared plus, oh, it's throwing two variables at us, plus 5xy minus y cubed. That's weird. I made my y's different. That's okay. And this time it gives us, it wants us to evaluate this where x is equal to 4 and y is equal to, x is equal to 4 and y is equal to negative 2. All right, so everywhere I see an x, I am going to substitute in a 4, and everywhere I see, I can highlight that for you actually. So everywhere I see an x, I'm going to substitute in the 4, And everywhere I see a y, I'm going to substitute. Oh, let's do different colors. Because we have two x's, so I'm going to do both those in yellow. And then I'm going to change the y to green. And everywhere I see a y, we're going to change that to -2. So don't forget, -2, it's tricky. I'm sure you will see me make that mistake and have to call me on it later, and that's okay. It is okay to make mistakes. So in this case, it's going to be -2 times 4 squared plus 5 times 4 times -2 minus, and then be careful, -2 cubed. Sorry, it's kind of smushed in there. So again, I don't have any operations happening inside parentheses. I just have numbers. So I'm going to skip to doing the exponents, and I have 2 of those. So nothing changes. I have -2, but instead of 4 squared, I'm going to put 16. I'm going to simplify. Plus 5 times 4, this isn't their turn yet, times -2, minus, and then instead of -2 cubed, I need to figure out what is -2 times -2 times -2. Well, I know 2 times 2 times 2 is 8, but be careful. We have a negative times a negative will give me a positive, but then when I multiply it by a negative again, it gives me a negative. So it's actually a -8 in the parentheses. So this time I have 2 negatives, which is going to change eventually to a positive. Whenever something to notice is that whenever you have an odd amount, like 3 negative signs, you're going to end up with a negative number. If you have an even amount, it's going to be a positive number. Like if there was just 2 -2s or 4 -2s you were multiplying, you'd get a positive number. So now multiplication or division. So here we're going to change -2 times 16 to -32. Check my mental math on that. Plus, and we're going to multiply 3 numbers together. 5 times 4 is 20 times -2 is -40. So actually, I don't want to put that plus -40. I'm just going to put -40. Like I said, whichever makes more sense to you. -40. And then we have this negative times this negative actually makes it a positive. So +8 minus a -8 is +8. And then we just go 3. -32. So if you're on a number line, I always think about it like this. Negatives are just direction. So like let's say zeros here. -32 just means we are going left of 0. So let's say we're starting at -32. And then remember, negative means left. We go left 40 more. So I need to go 40 more left on the number line, which will give me an even bigger -72. But then we're changing direction again. This +8 means now we go back to the right 8. So if I'm at -72 and I want to go back on the number line this way, we are going to be at -64. Somebody check my math on that. But I think that that is correct. Okay. So those are all of the examples for the order of operation. Now there are 3 checkpoints. There was checkpoint 1 underneath example 1, checkpoint 2 underneath example 2, and checkpoint 3 underneath example 3 that I'm going to have you do on your own. So you're going to want to pause here, or if I have figured out how to set it up in Edpuzzle, it should do it for you automatically. And I'm going to move on to the next section. So the next section, moving on to page 346, formulas and mathematical models. Okay. So we all know formulas and mathematical models, and you actually, I feel like they give them to you more in science than we actually do in math. I just had to remember or find or look up the one that changes